So both Jupiter and Saturn kind of have this sort of pale looking orangish, yellowish sort of hue to them. Just it looks like an artist has drawn some of these photographs that are taken of these planets. But what makes those sort of different swirly sort of colors actually has to do with the different types of hydrogen-containing compounds that are condensing. So, for instance, closest to the planet, we actually have water, H2O, condensing. It's kind of a whitish color. A little bit farther up in Jupiter and Saturn's clouds, it cools down to the point where ammonium hydrosulfide goes ahead and condenses, gives a certain color. And then even cooler, we have ammonia condensing. So we kind of have this sort of an assortment of compounds. Each one of these different compounds contain hydrogen that are actually condensing, much like water condenses to form our clouds. Okay. So each of the Jovian planets, Jupiter, Saturn, Uranus, Neptune, they have this sort of liquid condensing in their outer layers. It's not always just water, though. Okay, isn't that beautiful? So here we have the ammonium sulfide clouds, red and brown, ammonia reflecting white. So these swirly things right here, these would be different sort of kind of storms within the cloud layer of Jupiter. And some of them can last for a couple of weeks. And you've probably heard of the Great Red Spot on Jupiter. And I have a picture coming up. And actually that's an ongoing storm that has been around for about 300 years, at least 300 years. So switching gears to kind of see how Saturn has a similar in appearance to Jupiter. One of the things about Saturn is sometimes I think we are so stunned by Saturn's rings that actually if we were to maybe look even closer, maybe through a telescope, we would see some banding on Saturn. So both Jupiter and Saturn kind of have these bands going on. So Methane and Uranus are, Uranus and Neptune are both blue because of the presence of methane. And you can see how methane actually will reflect blue light and absorb the incoming red light. So here's again the picture we looked at before of Jupiter's Great Red Spot. It's a storm that's been going on for at least 300 years because a guy 300 years ago sketched it out. And you see this H here. This is actually on weather maps here on our world, on weather maps. Oftentimes meteorologists will look for central high pressures or central low pressures, and they'll have certain consequences to our weather. And so here we see that the Great Red Spot has a central high pressure, and it's making, it's not that dissimilar from an ongoing tropical cyclone. So here we have kind of side by side from left to right each of the planets. We have Jupiter, Saturn, Uranus, and Neptune, and they all have clouds, and they all have actually strong winds in their upper atmosphere, and they all have storms. You see this arrow pointing to this spot on Neptune that actually was called the Great Dark Spot. We have the Great Red Spot on Jupiter. Neptune used to have the Great Dark Spot, and that was a storm that actually has petered out now.